Alright guys, so this is part one of the linear combination / elimination lesson. And this should actually be a review from last year. Kind of like how you guys already learned substitution in 8th grade if you were in Janesville. You probably already learned elimination. Now depending on the person, this can be the easier or the harder one. For me, I personally prefer substitution. I know my co-teacher, Mr. Holt, prefers elimination. So it kind of depends person to person, and it depends problem to problem. Some problems are already easier to do substitution, especially if they have x equals something or y equals something already done. Elimination is when you don't really have that, when they both have x and y on the same side of the equation, then you probably want to do elimination. So first of all, up at the top, linear combination is just another name for elimination. So I believe that's your very first blank at the top. Okay, and what does it mean to eliminate? Well, eliminate means to get rid of, to cancel out, to erase. Okay, so our goal is, instead of trying to substitute something, we're trying to get rid of one of the variables so that we can solve for the other one. So step one, eliminate or get rid of one variable. And you might have to do a little work to do that. Step two, once you've gotten rid of one variable, solve for the other one. So if you're able to get rid of x, then obviously you're going to solve for y, and vice versa. Step three, plug the first variable into an equation to find the second one. In other words, if you get x equals 3 after you do all the work, plug in 3 and find y. And then, of course, check your work. If you know what x and y equal, plug them both back in. Make sure that they work for the equation. That's how you know you're correct. Okay, so taking a look at this one, obviously not good for substitution, right? There's no x equals, there's no y equals, so a good candidate for an elimination type problem. Okay, now my first thing to check is look for opposite coefficients. In other words, if I can find something that's, say, 2x and negative 2x, well, what's 2x plus negative 2x? Well, it's 0. That's where the elimination comes in. So look at my x's. Negative x plus 3x, well, that's 2x. That doesn't really help me. But look right here. What's negative 4y plus 4y? It's 0. That's what you want. You're trying to eliminate something. So we're actually going to add these two equations together. Those are going to go away. Okay, and then I'm going to combine everything else. So negative x plus 3x is going to become 2x. I'm just combining those two things. The y's are now gone. I've eliminated one of my variables. Negative 21 plus 15 is negative 6. Well, that's a super easy equation to solve. I now have something where I can get x by itself, and it's easy to do. So very quickly I find that x equals negative 3. Now again, remember, these are systems. That means you have to solve for both equations, or both variables, sorry. So go back to your originals. Which one looks like the easier equation to solve? Okay. Well, I guess it depends on personal preference. I'm actually going to pick the second one because I don't really like dealing with the negatives. So I'm going to do 3x plus 4y equals 15. In place of 3, in place of x, I'm going to put negative 3. And now this is just like substitution. Once I have one number, just plug it in. Now I'm going to have to do a little bit of work to get the y. That's what kind of stinks about elimination. Usually I have to do work to find the second variable. But this is just basic algebra. It's nothing too crazy. Nothing beyond your abilities. And there we go. And you know what? I could have done this by substitution, but it's more work because of how the problem's already built. All right, so that's why we're doing it this way. Pause here, take notes if you need to. All right, now remember that magic trick that we did? So this isn't on your notes page, but we did a little magic trick at the beginning of class. Okay, and I'm actually going to talk about how that works with elimination. There's a reason I was able to do that. Okay, now remember, I said pick two numbers, add them together, pick two numbers, and subtract them. All right, so somebody earlier told me that when they added their two numbers, they got 9. Okay, so I'm just going to use theirs. And when they subtracted them, they got -1. Okay, well that fits my little equation here. X and Y are obviously unknowns. I don't know what they are. When I put them together, though, looky here, I can actually eliminate the Y's. When I do that, I have 2x equals 8. When I divide by 2, I get that x equals 4. The trick that I was using in my head is that if you take the sum of the two numbers and you combine it with the difference, so 9 plus -1, I get 8. If I split that in half, that gives me one of the numbers. Well, in my head, I could easily figure out that 4 plus something equals 9. That something must be 5. Okay, so kind of a cool little trick. Not really magic, it's actually math. But you can fool people with it if they don't know what they're doing. All right, so let's move back to our notes now. All right, so looking at number 2, go ahead and try it. See if you can figure out where it is that you can eliminate. Hopefully you've already caught where you can do that. Take a look and see. And actually, I want you guys to do this one on your own. So please pause here, do it on your own, try it out. When you're done, check back. Okay, please don't just cheat and watch it. It doesn't help you at all. Pause here, do it on your own. All right, and then you'll get the answer for it. All right, so right there are opposite coefficients. The x's already are going to cancel out. Awesome. So let's add all these things together. I'm going to put a 1 right there just to help myself out. So I have -8y plus 1y. Well, that's -7y. 29 plus 20 is 49. Easy algebra problem. Divide by -7. Which must mean that y equals -7. Cool, I have half my work done. Still have to go back and solve for x. I'm going to pick the second equation. That one looks pretty easy to do. No negatives, just plugging stuff in. So I have 3x plus -7 equals 20. If I add 7 to both sides, I can get rid of my -7. And again, this is something you should have already done on your own. If you got it wrong, you can be pausing and checking and rewriting the work, but otherwise you should already have figured it out. And hopefully you got that x equals 9. Remember to rewrite it as a coordinate, 9, -7. That is where those two equations would cross on a graph.
Jennifer Larson, did you call 5262?
I get announcements stuck in my videos, so you might hear those from time to time. Alright, so number 3, you need to be careful with these types of problems, okay? Because right now, I can see a 6y and a 6y, which is great because that means that I might be able to eliminate them, but does -6 cancel out -6? No. It doesn't, which means I actually have to do a little bit of work here. All right, so because of that problem, I need to actually figure out how to get them to cancel out. So really I'm trying to get -6y and a +6y. That's my goal. All right, well, what do I have to do to a -6y to make it +6? Well, I have to multiply it by -1. Now, I can't just pick this by -1 and call it good. Whatever I do to one, I have to do to the other. So if I'm going to multiply -1 to that part, I have to do it to all the parts of the group. When I do that, now I get 5x plus 6y equals positive 10, which means when I combine this and this, now they're going to eliminate each other. So I'm actually just going to bring this guy down here. I don't like having it so far away when I combine. Notice I didn't change anything about that first equation, just rewrote it. Okay, and now I'm going to start to put it together because now these go away. 5x minus 7x is -2x. 10 minus 2 is 8. Awesome, now I'm back to the kind of work I was doing on the first few problems. So we get x equals -4. Okay, go ahead and pause here. See if you can find y on your own. Take x equals -4, pick one of your equations, one of the originals, it doesn't really matter which, plug it in, and then push play when you're ready to see the answer. I don't really like any of those, so I'm going to use, let's see, I'll just use the first one. Minus 6y equals -2. -7 times -4 minus 6y. Ugh, and I hate when there's so many negatives. Just makes so many opportunities for error. So many announcements interrupting the video. And I'm just letting you watch me walk through the algebra of that. Hopefully you got y equals 5 if you tried it out on your own. Again, write them out separate. X, comma, y. Okay, pause here. I'd actually like you to try number 4 on your own real quick. Do not just stop the video. You need to actually see what happens because this one's a weird one. But try it out, see what you figure out. Maybe even catch it before you start the whole equation. See what can you eliminate here. Do the work we just did on the last one. All right, hopefully you've tried on your own or at least looked over it to figure out what you might need to do. Now, if you actually caught it right away, you might already know what the answer is, but I'm going to do the math for it just to show you. I can't eliminate anything right now because I have -3 and -3 and positive y and positive y. Well, ideally I need a positive y and a negative y, or I need a -3x and a positive 3x. Well, that means one of them has to get multiplied by a -1 again. Change the signs, so I got to do it to all of them. So now this is going to be positive 3x minus y equals -1. I'll rewrite my first equation underneath. Again, all I did was multiply everything in the second equation by -1. So that's this guy. Everything in that changed by one sign. So now let's put them together. Well, 3x minus 3x gets me 0. -y plus y cancels out, gets me 0. And -1 plus 1 also gets me 0. So really it means 0 equals 0. Well, does 0 equal 0? Yeah, that's a true statement. There's no more variables. If it's a true statement after you eliminated all the variables, hopefully you already know where I'm going. It means that it's infinitely many solutions. The reason is because if you have the same exact equation, when you graph it, it's the same exact line. So those two equations actually overlap when you graph them, and every point is the same. That's why it's infinitely many solutions. Okay. Flip over to the back side and do 1 through 4. So 1, 2, 3, 4 is what you're working on now.